Hello everyone and welcome to our discussion for Book 1, Proposition 12 of Euclid's Elements. Proposition 12, to draw a straight line perpendicular to a given infinite straight line from a given point not on it. So the slight difference between Proposition 12 and Proposition 11 is the mention of the starting element, the point. At Proposition 11, the point is on the starting line, while Proposition 12, the point is not on the starting line. So this is another construct proposition which narrates the parameter of a straight line having two right angles. And we were going to cite this Proposition 12 when we mention such attribute or parameter. So here are now the components of the figure and of the proof. Obviously, we have the construct and the parameters of a circle. And yes, the radii are equal one another. So we have those details at postulate 3 and definition 15. And we will also be bisecting a line. And that has been shown at proposition 10. And we also have the parameters of the triangle congruence at proposition 8. And we also have the definition of right angles and its common line perpendicular to the line where it stands. So that's at definition 10. We have the terms right angles and perpendicular at that definition. Okay, so let's now proceed to the construction of the figure. So let's do it together by following these steps. So the first one, we'll draw the initial line AB. Okay, and we will going to have point C not on the line and at the northern part of AB. And we will also have point D at the southern part of AB. Okay, at the other side of AB. And we will now draw circle C with radius CD. Okay, there you have it. And now, as you can see, we have points of intersection here between circle C and AB, and we can have a point here, okay, that would be aligned or that would be along point C. So let's name those points. So the first intersection, point E, and then we'll have F aligned to point C. Okay. And we'll have another point of intersection for the circle C and line AB. And now we will going to bisect first line EG to define point H. So point H will be at the middle of EG, and H will divide EG into two equal line segments. And then we can start connecting some points. So CE, and we also have line segment CG, and the line CH going to F. Okay. All right. It's not so straight, but we'll consider that as straight, a straight line. Okay. So we have just constructed this figure in here. We have replicated this here. And observe that there is an equivalent triangle ECG and two congruent triangles ECH and CHG. So let's then show further and prove that indeed the triangles ECH and triangles CHG are indeed congruent to each other. Okay, let's do that. So, by the way, I would like to say that the foundation and the leading point of the proof is definition 10, because in definition 10, we have the definition for two right angles as angles that are equal and adjacent each other, and its common side is perpendicular to where it stands. Hence, in the proof, we just have to show that there are two angles which are equal and adjacent to each other. We are doing so by using parameters of an equilateral triangle and of the congruence of triangles. So now let's discuss the proof. The very first thing that we need to do is to identify the three pairs of equal sides, okay, to establish triangle congruence. So let's do that. So the first set or the first pair of equal sides would be EC and CG because these are radii of circle C. So that's one. And remember, we have point H bisecting EG. So we can say then that EH is equal to HG. So that's the second pair. And lastly, CH is equal to itself. So there you have it. We have the three pairs of equal sides. Therefore, triangle ECH is congruent to triangle HCG. And we'll use the parameters again of congruent triangles. It is saying that the angles and the sides contained inside those two congruent triangles are also equal. Therefore, we can see that angle EHC, this angle here, is equal to angle GHC, this angle. And these two angles are also adjacent. And furthermore, the common side CH is perpendicular to where it is all standing, which is line AB. So that would be all for Proposition 12. And thank you so much for watching and listening. Stay safe, everyone, and take care.